In the US and in many places around the world, gold mining is a big, high-tech, multi-billion-dollar industry with lots of highly skilled people and sophisticated tools. But how do miners find and extract this precious metal? To find out, let's journey to northern Nevada, home to one of the world's largest gold deposits, and tour a variety of operations with our personal guide, Natasha, who works for this vital industry.
Hi, I'm Natasha. We're here in northern Nevada to explore modern gold mining. From open pit operations like this, to underground operations that wind their way hundreds of feet below the earth. Join us as we find out how gold is made.
Of course, nobody really makes gold. Actually, gold already exists all around us in nature. But in most cases, except for the rarely discovered nugget or vein, it's just too small for us to see without a microscope. For most of today's miners, making gold really means collecting lots and lots of those tiny bits and pieces of gold and putting them together into larger pieces of gold that can be bought, sold, and used for lots of different things. To accomplish this, miners rely on a carefully planned sequence, or cycle of events. This cycle will be carried out through either open pit or underground mining methods, sometimes both. And the most important part of the process is the safety and well-being of the thousands of men and women who make this whole thing work. People are way more important than the gold they mine, so fully integrated safety programs make sure that they can do their jobs safely.
For surface operations, this cycle begins with a lot of highly educated professionals, ranging from engineers to geologists, who map out where the digging will take place.
Geologists use information obtained from sampling, testing, mapping, and observations above ground to create 3D computerized models of what the minerals look like under the ground. These models help crews mark and drill a pattern of holes that, when blasted, will safely and effectively fracture the rock for mining. Drill rigs bore hundreds of holes in a specific pattern for the blast. Before blasting, samples of rock from each of these holes are gathered and sent to the assay lab, where they are analyzed for gold content. This will help determine which rock will be processed as gold-bearing ore, and which will be set aside as non-gold-bearing waste rock. The blast crew loads each hole with a blasting agent, called ANFO, or ammonium nitrate and fuel oil. The holes are wired together in a specific sequence for a controlled blast. After all the holes are loaded, the area is cleared of workers and blocked off from traffic. Then a warning siren is sounded for several minutes to alert everyone on the mine site that a blast is about to take place. The blast fractures thousands of tons of material. Building-sized shovels and front-end loaders then load that material into giant haul trucks for the trip to the processing facility or to a waste rock facility, which we'll talk about later. One of these haul trucks is as big as an average 2-story house and can hold 240 tons of material, about the weight of 160 small cars.
For underground mining, the cycle is the same, but the equipment used is very specialized, and underground mines can be constructed in a variety of ways.
Portal mines are blasted and dug out through the slope of a hillside, or through the wall of an existing open pit mine. Shaft mines are developed from a large central hole dug straight down from the surface to several hundred feet, or even a few thousand feet below the surface. Like a portal mine, a shaft mine has different levels, with the central shaft usually going all the way down to, or even below, the lowest mining level. A network of interconnected access ways branch off from the central shaft at different levels, and, as in a portal mine, are linked with connecting ramps. But unlike in a portal mine, large machines and equipment, as well as the gold-bearing ore and the miners, cannot just be driven in or out. People and machines have to be transported in a large, elevator-like device called a cage. which is hoisted up and down the shaft from the adjacent hoist room. The ore is transported up the same shaft by a separate device called a skip. The blast holes underground are drilled horizontally into the rock with large machines called jumbos. And, as with surface mining, samples are gathered from the holes and sent to the assay lab. Next, the blast crew arrives at the drilled-out rock wall called the face. They load the blast holes with an ANFO-based emulsion and then wire them together for a specific blast pattern. Once the ore is fractured, a loader scoops it up and loads it into underground haul trucks for transportation to the process facility. The last part of the underground mining cycle is the installation of proper ground support, so mining can safely proceed.
So now that the ore is out of the ground, it needs to be processed. As mentioned before, the gold we mine is microscopic in size, and the process to extract it out of the ore is very complex. Let's take a look at how this is done through engineering, chemistry, and the other innovative techniques that we use to get the gold out of this rock.
Because geologists studied the rock before the blast, they know which areas of the blasted material contain high or low-grade ore. If the ore is low-grade, then it typically goes to a leach pad. If it's high-grade, then it goes to a mill, autoclave, roaster, or other processing facilities to prepare it for the final stages that combine the scattered, invisible gold particles into solid masses of gold that can be seen and used. A heap leach, or leach pad, is a large pile of low-grade ore which is carefully placed on top of a specially designed liner that looks like a giant, thick sheet of black plastic. This liner and the deep layers of other dense, natural, and man-made materials on which it lays help prevent the leaching solution from entering the ground below. A long network of pipes drips a diluted cyanide solution onto the ore. The gold in the ore is dissolved and becomes part of the solution trickling down through the pile to the bottom of the pad. The function is roughly similar to that of water percolating down through coffee grounds in a filter. As the gold-bearing solution accumulates at the bottom of the leach pad, it's pumped into a man-made reservoir. It then goes through a series of tanks, each containing a large quantity of finely ground carbon particles, which attract the dissolved gold particles. By the time the solution exits the last tank, it contains very little, if any, of the gold it had when it entered at the top tank. The solution is continuously recycled through the leaching and carbon recovery process to ensure the recovery of as much gold as possible. High-grade oxide ore is taken directly to a crusher, which breaks large ore pieces into smaller ones before sending them on to a mill. The mill progressively grinds the ore down into a smaller, finer, sand-like consistency. Some higher-grade gold ore needs special treatment before it can join other ore in the carbon leaching process. In most cases, ore from deep underground contains a lot of naturally occurring minerals and chemical compounds. These elements can encapsulate or surround a gold particle, creating a barrier that prevents leaching solution from reaching and dissolving it. Either through an autoclave or a roaster facility, these natural barriers have to be stripped away or artificially oxidized through exposure to strong chemicals or high heat. These treatments essentially do in minutes what nature does over thousands or millions of years. Eventually, all processed ore, now fully oxidized, ends up in a solution called slurry, which moves through a series of tanks containing a mixture of weak cyanide solution and carbon. The gold bonds to the carbon, which is then separated from the slurry by pumping the slurry over mechanical shaking screens. The carbon is sent through a chemical stripping stage, which pulls the gold back out of the carbon to create a gold-rich solution. The resulting solution is channeled through an electrochemical process. This process, called electrowinning, uses an electrical current to attract the gold particles to special screens made of a steel wool-like material. The gold particles bond together on the steel wool masses, ultimately forming a visible layer of gold, about the consistency and thickness of heavy foil. The resulting material is placed into a furnace and heated to more than 2,000 degrees Fahrenheit. This molten material is then poured into a gold doré bar, containing up to 95% or more pure gold. The doré usually represents the last step of gold recovery that happens on the mine site. After it's poured, weighed, sampled, stamped, and labeled, the doré is shipped off-site to a high-tech commercial refinery, where it's melted down to create gold bullion, which is nearly 100% pure.
So now that the process is complete, what happened to all of the waste material that was moved to get the gold? Well, I'm standing on it. This is a waste rock pile that has been reclaimed. Reclamation is a vital part of modern mining, so let's learn a little bit more about it.
Areas no longer needed for mining are reclaimed or turned back into a stable land resource, which is contoured and seeded with native grasses and plants to match the undisturbed land around it. When possible, this reclamation is done concurrently or while mining continues nearby. This reduces the amount of reclamation work needed when the mine is finished operating, and it provides a head start on the overall rehabilitation of the land and environment directly impacted by the mine. Ultimately, after all mining is done, the entire mine site is reclaimed, so that after a few years, it'll be difficult to tell that any mining ever took place at all.
So why do we mine gold? Jewelry, gold coins, gold bars are some of the first things we think of. But nowadays, there are actually many more uses for gold.
Because it does not corrode or degrade, gold is one of the best electrical conductors around, making it ideal for use in manufacturing reliable and efficient electronic products. Nearly all TVs, computers, mobile devices, smoke and carbon monoxide detectors, and other everyday items contain gold circuitry or other components. In the distant past, mine workers were people who basically just moved dirt and rock through hard manual labor, or in later years through the use of heavy equipment. But today, mine employees include equipment operators, engineers, geologists, accountants, information technology specialists, warehouse technicians, mechanics, welders, instrumentation technicians, electricians, environmental coordinators, human resource specialists, communications and community relations representatives, safety coordinators, and many other professionals. It's only through the collective efforts of these highly skilled, hard-working, responsible people that the complex undertaking of modern mining is successful.
As you've seen in this video, mining today involves far more steps than it did hundreds of years ago. It is now a serious business, driven by the minds and hands of thousands of dedicated people, each important to the mining process. We thank you for taking your time to learn about modern mining, and we encourage you to share the knowledge.